Good morning, everybody. I hope you all had a nice weekend. We're going to continue our discussion of Chapter 3 today. And before I do that, let's share our screen. And we see over here a properly drawn tetrahedron. I did not explain this word yet. Chirality. Chirality is merely another way to say handedness. Just like your right hand and your left hand are different objects, molecules that are chiral are handed. Handedness. I'm going to prove to you that this is a handed object. And let's do that right now. I want to just prove this fact that this thing is not identical to what looks like its mirror image. If you pretend there's a mirror here between the two objects, you would see the same distance away from the mirror as A, and straight down is a bond to the stereogenic center. We already know that, what that is. And we see going away from the mirror and down is B, and going away from the mirror and down is B here as well. Towards the mirror and going down on a dash is D. Towards the mirror and going down on a dash is D. So if you were describe these with respect to the mirror, the descriptions of both molecules are identical. We need to prove they're not. So I'm going to copy the tetrahedron. And when you do a horizontal flip, that's this flip here, you got your hand and you flip it. Then let's just use the hand like this and say that's A and this is B. If you flip it, the A is still straight in the air, but the B is on the other side, right? So let's put the A and the B on. Move that a little more. The A is still straight up. Oh, I didn't flip it. I'm supposed to flip it. Here we go. Flip horizontal like the instructions say. And the A will still be straight up. And the B down. Now I gotta look at what happened to the C and the D. So let's get our hand back up here. Yeah. Now pretend there's an object sticking out of your hand. Okay, let's make an object that you'll remember. There's a nail sticking out of your hand, out of your palm. And right now it's coming out at you and going away from me, by the way. And when I flip it, now it's going away from you and towards me. So which bond was sticking away from you? C. When we do a rotation like this, it's going to go behind the page. And similarly, the object that was behind the page and to the right will be in front of the page, and to the left when we flip it. So these are the same molecule. There's just a rotation this way. I'm just going to copy this molecule down here. No rotations at all. And I'm getting extra stuff because I didn't plan that 100% the best, but I think I got away with it. Now, the only question is, are they superimposable? Are they superimposable? Are these two things superimposable And let's try that. Let's just try it. Let's take this thing here, copy paste, and I'm going to group it. Yeah. And then copy paste, group it. And I'm going to try to put them on top of each other. And I see that we have matches for A and B. Match. Match. But here, mismatch means they're not the same, which means they're not superimposable. Oh, went a little too far down there, didn't I? Mismatch there, and also mismatch down here. C and D are not the same thing. And the answer to the question, are they superimposable, is down here. And here it is, answer. No. So we know they're mirror images of each other because these are the same molecules. This one's the same as this. I just rotated. I didn't change the molecule. This is Dr. Whitaker. This is still Dr. Whitaker. Okay, got it? This was the mirror image of Dr. Whitaker. And if he was chiral, and then today I am chiral with this little gizmo here, right? It's not over here. It's only over here. And yeah, so this is the same as this. I mean, clearly, I just moved it down after I made a copy of it. And these are two objects that are mirror images, and they're not superimposable. Control T. You didn't need to know that. Control T. Two objects that are non-superimposable. That's a fancy way of saying they're different. Mirror images of each other are a form of isomer called, big word of the day, one of them, there's many big words, enantiomers is one of them. Yeah, oh boy, it disappeared. I wasn't finished with it. This is very hard, but I can get it to work. I hope. All right. Two objects that are non-superimposable mirror images of each other are a form of isomer. Isomers. They're two objects, right? They're a type of isomer. How's that? Type of isomer. Of isomer called enantiomers. That's an important new word. And yeah, it needs special color. Enantiomers. So, take home message here. No, yeah, that's a good spot for it. Each object is chiral. Each enantiomer is a chiral molecule. This page is getting full. So let's get a new page going here. Chiral. An object, and gets underlined 4 times. Is chiral if it is not superimposable on its mirror image reflection. Okay. Hands are a good example of this, right? Try to put your right hand on top of your left hand and the fingers don't match up. They are clearly mirror images of each other. Just put them in front of each other and they have the same parts, but they're not superimposable on each other. So they're different objects and they're chiral objects. So students often get confused. What's the difference between chiral and an enantiomer? Well, chiral, you're looking at only one molecule. You don't need the other one to exist. So you say, okay, if there was a mirror image of this, it would have the thumb over here on the mirror, but the thumb would, the thumb has to face towards the mirror. So it's really going to look like this, but it's, I don't need that thing to know. And then you try to put them on top of each other and they don't match up. So they're chiral. The pair of them, if they have the same parts and they have the same description on each side of the mirror, remember how I described these two molecules at the beginning? Here's the mirror right here. A is the same distance from the mirror straight up. B is the same distance from the mirror and to the left. Don't say to the left. Away from the mirror. Here's the mirror. Away from the mirror and down. And B is away from the mirror and down the same distance. C is towards the mirror and outwards and down. Towards the mirror and outwards and down. And D is towards the mirror and back behind the page and down. And D is towards the mirror and down and behind the page. So they're definitely mirror images of each other. We did the exercise here where we did a horizontal flip so I could at least have two of the groups match. When the other two didn't match, then I knew each object was chiral. And because they are mirror images of each other to begin with, they are also isomers called, what's the name? Enantiomers. And there's two big words for today. Chiral and enantiomers. Now we're going to do an exercise to get us to the end of our first segment. And this exercise will guide us towards solving a problem that will be on our next test. And the problem will be drawing all possible isomers of a molecule that has two stereocenters. So what I'm going to do is do a guided exercise here. And I want you to draw 3R, 5R, 3,5 diiodo, 5 isopropyl, decane. This will be part 1. Okay, that's just a straight nomenclature question. If you want to get real picky when there's multiple stereocenters, we put them in front and we put numbers in front and we put parentheses. When I'm grading nomenclature, if you do something like forget the parentheses, you're not going to be in trouble with me. So how do I approach this problem? Well, I draw it without wedges and dashes, and I just put all the groups on that I need to put on. And remember, if it's a stereocenter, I need to see all 4 things attached to the stereocenter. If I don't see all 4, you're going to be losing partial credit. So here we go. We're going to have a decane, 2, 4, 6, 8, 10. On carbon 3, there's an iodine. On carbon 5, there's an iodine. On carbon 5, there's also an isopropyl. So stereocenter 5 already has 4 groups showing. 4. Carbon 3, you better show me the hydrogen or else you're going to lose some points. Okay. Now remember the tricks I told you to do for creating new stereocenters? If you connect the 1 and 2 and 3 and you get the right result, then put the 4 on a dash. If you connect the 1 and 2 and 3 and get the wrong result, then put the 4 on a wedge. We're just going to do that again. We've been doing that already. And the stereocenter on the left here has iodine for 1, hydrogen for 4. The CH2 here goes to a C with an iodine. The CH2 here goes to a C that does not have an iodine. Iodine's very heavy. That's a very funny looking 3. And I was unlucky. That doesn't mean anything, unlucky. 1, 2, 3 is currently a counterclockwise, which means if you put the 4 on a dash, you will be losing 3/4 of a point because you will have an S stereocenter. I do not want an S stereocenter. So I'm going to put the number 4 group on a wedge and pick any of the adjacent bonds to be the dash. This one's convenient, it's adjacent. Repeat on the next stereocenter. You do 1 for iodine. This one, some people are already thinking this is 2 again. Is that wise? That is not wise. This is a C with 1 more bond to C and 2 bonds to H. This is a C with 1 more bond to C and yet another bond to C. It already beats this one. I did not get as far as the iodine to make a decision. I made the decision before that. Remember, doing stereocenter is not about groups. It's about one atom at a time and asking yourself, what's the heaviest thing attached to this atom? Or what is the heaviest atom? That's the first question. Then 2, if there's a tie, move on. What's the heaviest thing attached to this atom? And then 3 is here and 4 is here. I was lucky this time. No, I wasn't. I was unlucky both times. 1, 2, 3 is currently counterclockwise, and I need it to be R. If I put the 4 on a dash right now, this is S. Sadness. We don't want sadness. Put the 4 on a wedge. Choose an adjacent bond for a dash. It could be either this one or this one. I'm just going to choose this one. Make sure your dash goes all the way. Don't stop dashes halfway. If you stopped your dash here, say you did this instead, and then the bond continued here, right there is a carbon you just added. Your isopropyl became isobutyl. Some of you who studied really hard and looked at old exams and answer keys saw these notes that said, do not make a dash stop halfway. If you did not see these notes, then maybe next time you want to look at everything that's available to you, because not using things that are available to you is not doing as best as you can. Okay, so 1, 2, 3. Here's how I like to say it. Because the 4 is on a wedge, 1, 2, 3 is not S. And guess what it is? If it's not S, it's R. Okay, part 1 is done. 2. Let's see what I can do here. 2, I want to draw this one. And this was 1. And 2, I want to draw 3s, 5s. I hope nobody's surprised that my approach is to realize that that first one you drew is going to be the mirror image of this one. What's the mirror image of an R stereocenter? It's an S stereocenter. Just like the mirror image of a right hand is a left hand. The mirror image of this R stereocenter is another S. So do not be surprised when I do this. When I'm asked to do number 2, here's the first thing I do. I pretend, I don't have to draw this, but I'm pretending there's a mirror right here, and the same distance away from the mirror, CH2, 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 C, and then I'll just do it as zigzags first. Oops, missed. Need more room. So I'm currently up to here, and going here, and I'll do the wedge in a second. It goes down, up, down again. And how many carbons in from the mirror is this? It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it's a wedge upwards towards the mirror. I even put it in blue. Describe the dash relative to the mirror. It's downwards towards the mirror. It's got a nice isopropyl on it. Describe the bond to iodine relative to the mirror. It's not away from, it's not a wedge or a dash, and it's a little bit away from the mirror and down. Now, even if you're like me and you have you're spatially challenged, you can't do this stuff in your head. I mean, just use the mirror. The iodine's the same distance from the mirror, so is the isopropyl. This H is on a wedge towards the mirror and down. This H is on a wedge towards the mirror and down. Oh, put it in blue. And there's an H. The iodine is on a dash away from the mirror and down. And congratulations, you finished part 2, and you didn't have to do any hard work at all on the stereocenter, did you? No hard work whatsoever. You didn't have to figure out R and S on it. You just realized the mirror image of this 5S. 5S is 5R. Oops, I did that backwards, didn't I? The original was R. The mirror image of this 5R.
Doctor?
Hello. Oh, that scared me. Sorry. Is this 5S? Yes, go ahead. Sorry.
The voice got really low. I'm not sure if it's just my phone or it's a
probably
technical
not.
problem.
It's really low. You're not. Is that better now?
It's really, really low. Like we can't hear you.
You can't hear me. I don't like it. That's not good. Maybe we'll take a break. This is actually not a bad spot for a break, and I will look into that, okay? And we should pause about this time anyway, and we'll come back and pick up right from here. I will reboot my computer. Maybe that will help, and I will check volume levels. I don't know if you caught that, but I'll be back.